Hello everyone, my name is Anupam Datto and I am a second year student in the Department of Electronics and Communication Engineering of Kuchbihar Government Engineering College. Today I am going to discuss about the concept of modulation of subject analog communication. This presentation will cover the basics of modulation, its types, advantages and applications in modern communication systems. To begin, let's understand what modulation is. Modulation is the process of modifying a carrier signal to encode information for transmission. This process is essential because it allows signals to travel long distances without degradation. Modulation is the backbone of efficient communication in systems like radio, television, and wireless networks. It also enables frequency multiplexing, which improves bandwidth utilization. In simple terms, modulation makes communication possible over vast distances and across various platforms. Now, why do we need modulation? Modulation serves several critical purposes in communication systems. First, it overcomes signal interference and noise, ensuring clear transmission. Second, it facilitates multiplexing, allowing multiple signals to be transmitted simultaneously. Third, it enables long distances communication by modifying signal properties for better propagation. Additionally, modulation reduces the size of antennas required for efficient signal reception and improves bandwidth utilization. It also enhances data transmission speed and efficiency, ensuring reliable communication in both urban and remote areas. Now I discuss about the types of modulation. Modulation can be broadly classified into two categories: analog modulation and digital modulation. Under analog modulation, we have amplitude modulation, frequency modulation, and phase modulation. On the other hand, digital modulation includes techniques like amplitude shift keying, frequency shift keying, and phase shift keying. Each of these techniques has its unique way to encoding information onto a carrier signal, which we will explore in the upcoming slides. Let's start with amplitude modulation. Amplitude modulation is a technique where the amplitude of a high frequency carrier wave is varied accordance with the instantaneous amplitude of the message signal. Here the carrier signal amplitude changes based on the strength of the input audio signal, while the frequency and phase remain constant. Amplitude modulation is widely used in radio broadcasting due to its simplicity. Next, we have frequency modulation. Unlike amplitude modulation, frequency modulation varies the frequency of the carrier wave based on the message signal while keeping the amplitude and phase constant. In frequency modulation, a higher amplitude in the message signal increases the frequency division while a lower amplitude reduces it. Frequency modulation is known for its better noise immunity and is commonly used in radio and audio broadcasting. Now let's discuss phase modulation. In phase modulation, the phase of the carrier wave is varied in accordance with the instantaneous amplitude of the message signal, while the amplitude and frequency remain constant. The working principle of phase modulation is that the phase of the carrier signal changes proportionally to the amplitude of the message signal. A higher amplitude causes a greater phase shift. Unlike frequency modulation, phase modulation directly affects the carrier's phase rather than its frequency. Moving on to digital modulation techniques. These techniques encode digital information onto a carrier signal by varying its amplitude, frequency, or phase. The main type of digital modulation are First, amplitude shift keying represent digital data as variation in the carrier amplitude. Second, frequency shift keying represent data using changes in the carrier frequency. Third, phase shift keying use phase variation to encode data bits. Fourth, quadrature amplitude modulation combines amplitude shift keying and phase shift keying for higher data rates. These techniques are essential for modern wireless and broadband communication system. Now, let's look the advantages of modulation. Modulation offers several benefits including efficient signal transmission. Signal can travel long distances without excessive loss. Better noise immunity. Modulation reduces the impact of noise and interference. Multiplexing capability. Multiple signals can be transmitted simultaneously. Improved bandwidth utilization. Optimizes the use of the frequency spectrum. Enhanced signal quality, maintains signal integrity in challenging environments, compatibility with different media, works across radio waves, optical fiber, and satellite links, increased data rates. Digital modulation supports high speed internet and mobile communication. Modulation has a wide range of applications in various fields. Some of the applications include radio and TV broadcasting. Amplitude modulation and frequency modulation are used for transmitting audio and video signals. Wireless communication essential for mobile network 2G, 3G, 4G, 5G, Wi-Fi and Bluetooth. Satellite communication used in GPS, television broadcasting and space communication. Optical fiber communication. Digital modulation enables high-speed data transmission. Industrial and IoT applications support real-time monitoring, automation, and smart city infrastructure. In conclusion, modulation is a fundamental technique in communication system that enables efficient signal transmission over various media. It allows for long-distance communication, noise resistance, and optimal bandwidth utilization. Analog modulation techniques like amplitude modulation, frequency modulation, and phase modulation have been crucial in traditional broadcasting, while digital modulation techniques like amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude modulation are essential for modern wireless and broadband communication. The advancement of modulation techniques continues to drive innovation in telecommunication, satellite communication, IoT, and high-speed data network. Understanding modulation is key to developing efficient and reliable communication system in the future. Thank you.